next part, part B, asks how far over horizontally does it land? What's this distance, or what's this range, say? Well, that's pretty simple. You know the velocity horizontally. You know the time that it has before it hits the ground. The question is, how far can this velocity take the rock in this amount of time? That's a constant velocity.
Okay, how are you?
And the kinematic equation for that is the simple one with no acceleration. Your final position is equal to your initial position plus your movement through time. Final position is radius, is this range. Your initial position, if you lay down the origin here, this can be 0 in the x direction. You know your velocity, that's your initial velocity in only the x direction. And then you have a time, which you know the time. You know all of this. This is an easy equation to solve. Part C. I think this is the interesting part. At the instant the rock hits the ground, how far is it from the basket? Well, it took 9 seconds to hit the ground. And we know, we've just calculated how far out that is. And we know the basket is straight above, we're going to call the basket straight above the origin. So the basket is definitely a distance r away. We've just calculated that. So there's the origin. So the rock is there. There's where the rock is. Now, we calculated the original height. So we would know that it's just this hypotenuse here. But in the 9 seconds that it took the stone to hit the ground, in 9 seconds this balloon has moved down. It's moved down some distance. And the question is, how much is that distance? Well, that distance can be calculated. It's moving constantly. This is a constant. It says that the balloon is in a constant velocity downwards. We know that weight is pulling it down, is trying to accelerate it down, but there's also a balancing force from the balloon up. And if those two are in balance, then there's no acceleration, and it will have just a constant motion downwards. So this kinematic equation, which you don't often see because usually motion in the vertical direction is not without acceleration, not usually the constant velocity. The final position, which we don't know, is equal to, actually I'm not even measuring this distance, I'm going to measure this height here, this y final, is equal to the height, that's the initial position, plus the velocity, which is this VIY. Now for me it was 20 meters, and remember that's downwards, so that's going to be a negative value. You start off with at a positive distance with a negative velocity. So that's minus the VIY, and time is 9 seconds again. You know that time. You can plug everything in there and figure out the height that the balloon is at when the rock hits. So you actually have this triangle you're going to be examining. This triangle is going to have one side equal to, the vertical side will be a length equal to y final, and the horizontal side will be length equal to r. You can use Pythagoras 3 or 4,000 year formula to figure out that distance, which is the distance between the rock and the balloon at the time of impact. A squared plus b squared equals c squared. A, B, C. Good luck.